start off today by writing down is that conventionally in Algebra 1, it's looked at as bad form to have a radical in the denominator of a fraction, right? It would be considered bad form for me to say, here, Paul, here's a fraction, 1 over the square root of 2, okay? And so as an exercise, what we do is we learn to get that radical out of the denominator, okay? So down here on your screen, I want you to look at part A. It's 4 over the square root of 3. So if I've just told you that's bad form, it's considered unconventional to leave a square root in the denominator, what are we going to do about it, okay? This process is known as, quote, rationalizing the denominator, okay? Write that phrase down, rationalizing the denominator. And what that means, you think about the word rational, right? A rational number is a number that can be expressed as a ratio of integers. In other words, square root of 3 is not a rational number. That denominator, therefore, is irrational. And so to rationalize it means to get the square root out of that, okay? Now, let me ask you guys, what do we have at our disposal as far as tricks of the trade, as far as tools in our tool bag, whatever analogy you want to use? What do we have that we can do to a fraction? Paul? Louder. Okay, least common multiple would be usually when we have more than one fraction, like when we're adding them. Okay, so that's not a bad idea. And you're hunting in the kind of the right ballpark here. What do we do to fractions? What are we allowed to do? You guys have done this before this year. Something that you could do to a fraction. Multiply by what? Yeah, very good. We can always multiply by 1. That's the multiplicative identity, right? You can times something by 1. Now look, if I times this by 1, if I wanted to say, oh, I don't know, 7 over 7, could I do that? Heck yes, I could. And the result would be 28 over 7 square root of 3. Womp, womp, womp. Did that get done what I wanted to get done? No, it did not. Okay. So 7 over 7, although that's a clever form of 1, I just made that up myself. That's a clever form of 1, as Drew suggested. That's the wrong clever form of 1. Okay. So my question to you becomes, what clever form of 1 would get rid of that square root? Jack?
3.
All right, let's try 3. 3 over 3. The top is 12. The bottom is 3 square root of 3. Womp, womp, womp. All right. I need that sound effect from The Price is Right, you know, when they go over. Dum, ba-dum, ba-dum, bah. You guys know what I'm talking about? That's like a meme now, I think. Anyway, I need a sound effect button for that. But no, you're getting closer. You're getting closer. Okay, James? 3 squared. Is that what you're saying? 3 squared? All right, so 3 squared is 9, so that would be like saying 9 over 9. So I'd have 36 and 9 square root of 3. All right, it's not 3 squared, but we're so close we could spit on the answer. Okay? It's not 3. It's not 3 squared. Luke? All right, negative 3 would be negative 12 on top, and negative 3 square root of 3 on bottom.
Would it be the square root of 3?
Discouraging you guys. I'm sorry to be discouraging today. All right, let's see. I've heard from you two guys. I'm going to get somebody fresh. Somebody hadn't answered just yet. Drew, I've heard from you. What do I know that when times by square root of 3 makes the square root go away? Did I dadgum call on you, Paul? You and your correct answers can just get out. Now, you're absolutely right. Square root of 3. All right, so square root of 3 over square root of 3, is that a clever form of 1? Yes. Okay, so I got 4 square root of 3 on the top, and then what's the square root of 3 times the square root of 3 on the bottom? Square root of 9, which is 3. And now my denominator is rationalized. There is no longer a radical in the denominator. Now, I get students all the time that will say, well, Coach Morgan, your answer's a lot more complicated looking than your problem. And you're supposed to be, quote, simplifying it. I know. You're preaching to the choir. All right. The aforementioned 1 over square root of 2 is the same thing as square root of 2 over 2, which is, it's got more going on. But as an exercise, by getting the radical out of the denominator, okay, although it might make my answer look a little teensy bit more complicated, it makes my answer more conventional. And I now have learned a new trick of the trade, how to get rid of a square root, okay? How would I go in orange there from 1 over radical 2 to radical 2 over 2? Yeah, just times square root of 2 over 2. Square root of 2 over square root of 2. The top is simple enough. Square root of 2 times 1 is square root of 2. And then the bottom, square root of 2 times square root of 2 is 2. Okay? You guys do one. 1 over square root of 3. Now don't be silly and multiply it by square root of 2 over square root of 2 again. We want something different. Alex, what'd you get? Attaboy, square root of 3 over 3. All right, shall we try one more? How about 1 over square root of 5? I'm skipping 4 because that's just 1/2. 1 over square root of 5. Are you picking up on a pattern, Mossy? What do you think that answer is going to be without actually having to do it? Very good. Pattern recognition's tight. I like it. All right, so when we are rationalizing the denominator, sometimes, yeah, we can memorize our answers. Like I've got square root of 2 over 2 memorized because that comes up in trigonometry a lot. But we can also just do it in our head. If it's a simple rationalization, let me push you guys to learn to do that type of thing in your head. Okay? Now, you look at part B. Let's clear some space up right here. You look at part B with me. Okay? And what must I do first? I got a big fat square root of 3 over 20. What must I do first there, Jack Candiato? Very well said. If you didn't hear that, he said you have to take the square root and apply it to 3 and to 20 separately, okay? Now, before I get all crazy and start multiplying by the square root of 20 over the square root of 20, all right? Joey, can you help me simplify that denominator first? Because square root of 20 could be simplified a little bit. Oh, 10 and 2 is a way to split it, but not the best way of splitting it. Think again. 10 is not a perfect square, nor is 2. Pick another factor pair of 20. Ah, boy. And square root of 4 I know to be 2. So this is the same thing as square root of 3 over 2 square root of 5. Right? Okay, square root of 3 over 2 square root of 5. Now, Lewis Thomas, what do I multiply the top and the bottom now by to get rid of that radical in the denominator?
Square root of 5.
Very good. So we're going to times this by a clever form of 1, in this case, square root of 5 over square root of 5. Okay, Ben, what does that make the top? Good. And the bottom? That a boy. I love it. Walked through the whole process for me. I didn't even have to say a thing. If you didn't hear what Ben said, he said 2 times the square root of 25, which is 5, which 2 times 5 is 10. Now, if you're like, huh? Where did that come from? Just look at what we're doing. We're multiplying on these two denominators. We're multiplying the coefficient times the coefficient and the radicand times the radicand. In other words, what's on the inside by what's on the inside, what's on the outside by what's on the outside. Tiago.
Why should the denominator not have?
You know, that's a fabulous question. In terms of Algebra 1, I really think it's more like an exercise. They're teaching you to manipulate by saying it's bad form to have a radical. Because when you get into calculus, you'll be fine having a radical in the denominator. Okay? So I kind of think, I don't want to say they're lying to you by saying you can't have a radical in the denominator. You know, I think they're just pitching this to us as an exercise. They're saying, by the way, it's unconventional to have a square root in the denominator. So learn all this new math to get rid of the square root. And then after you've learned the math, they're like, ha, you didn't really have to do that, but now you know how to do it. Because a little bit later on, you'll have, this is getting into calculus, right? But you'll have something like the limit as x approaches 1 of the square root of 1 minus x plus 5 over x squared minus 1. You'll have something like that. And you'll be taught to just let x be 1. You plug it in, you get 0 on the top, 0 on the bottom, and then you're like, what do I do? 0 over 0. And guess what? At that point, your teacher's going to whip out this and say, what could I multiply by on the top and on the bottom that would get rid of that square root in the numerator, right? And you hearken back to these days as we little 8th graders, and you say, I remember Coach Morgan taught me how to rationalize things. And how to rationalize, in this case, the numerator is going to serve me in that later context in calculus. Okay. Now, that's a binomial numerator, which we're about to get to. But let's finish up with monomials. Okay. So we done part B. Let's do part C. Okay. And actually, I'm going to let you guys chew on part C on your own. Okay. It's got a variable in it. Don't let that freak you out. Okay. But get the square root out of the denominator. We've done a couple together. You're going to do one on your own. Nate, what are we multiplying by? I'm not going to bust Nate's chops, but because I know exactly what Nate's talking about. How should we have answered that question? What are we actually multiplying by? 1. Which clever form of 1 it takes is square. And again, I knew exactly what you meant. Square root of 6x over square root of 6s. But I just want to hammer down that point that the reason we're able to do this is because we can always multiply by 1 whenever we want to. Okay. And in this case, a clever form of 1 is going to get the job done. So, Andrew, what's my numerator going to be? And denominator. Fabulous. Now, Charlie, if I were to leave my answer looking like that, I would be wrong. Why would I be wrong? Correct. What would I need to do to simplify it further? Yeah, there's a 3 on the top and a 3 on the bottom. So this is square root of 6x over 2x. Okay. Quentin, can I cancel out the x's, by the way? I see x on top and bottom. Can I cancel out those x's? So you're correct in that they're not being added. You're incorrect in that you can cancel them out. All right. So I like where your head's at. He knew I cannot cancel common terms. I can only cancel common factors. And yet here I am being a turd and saying you can't cancel these common factors out. Why not, Will Edwards? George Booth? Yes. There is an operation being done to 6x that trumps the operation of division. Remember your order of ops? What's everything that comes before division? Excuse me. Don't you dare say multiplication, by the way. What's everything that comes before division? Parentheses. Exponents. Okay, good. That's it. So the square root of 6x is the same thing as 6x raised to the 1/2 power. We've talked about the phrase that pays in here before, right? What's the phrase that pays, Jake? Maybe we haven't talked about it in here before. Power over, who said that? Luke? Am I going crazy? Have I said that in class before? Power over root is the phrase that pays. All right, what that means is that I can take something like check this out. Look, 6x is actually raised to the first power, and it is actually under the square root. So the square root of 6x is the same thing as 6x to the 1/2, and that exponent trumps the division sign. All right, what that means is that I got to do the 1/2 exponent before I try doing the divide by. And the divide by is where our cancellation comes in, right? So in other words, this x is locked up tight inside the house with the 6, so to speak. I cannot cancel out, even though they're factors, I cannot cancel any of them out. All right? So real important question there. Does it make sense, you guys? Everybody? Okay, just because I see something in the radicand, it does not mean I can cancel it out. All right, now that's rationalizing the denominator of a basic, monomial kind of setup. Monomial means what? One term. Okay. Now, I do need to talk about these. We won't do all 3 of these, but those are all square roots. The same sort of mentality applies with higher roots, okay? With higher roots. So, like, check this out. Look at example 1 right here, or excuse me, part A. I got 1 over the cube root of 6. Now, just off the cuff, like, what do you think I should multiply by? Just tell me what you think I want to hear. Cube root of 6. Okay. Clever form of 1. Cube root of 6 over cube root of 6. Now, if I do that, I'm going to get the cube root of 36. So cube root of 6 on top, cube root of 36 on the bottom. Is 36 a perfect cube? It is not. It's a perfect square. It ain't a perfect cube. So does that denominator simplify out? No, it does not. Now, although these 2 fractions are equivalent, the second one is no better than the first one in that it's still got a radical in the denominator. So I'm going to re-ask the question now. What clever form of 1 should we multiply by to get rid of that cube root? James? Attaboy. Because if you look at the 3 as, and you know, have we talked about like the quote jailer approach in here? Have I mentioned that any? Okay. Like if you look at that 3, he is saying, hey, psst, I'll let you out of jail as long as there's 3 of you. Okay. Like jail being inside the radical sign. And so like there's 1 6 right there. How many more 6s does he need to get out of jail? He needs a couple, hence the cube root of 36. Okay. So you could look at it as though, man, I've only got 1 6 in there. I need 2 more. So the cube root of 36 over the cube root of 36, that's my clever form of 1. Now the numerator is easy. That's just cube root of 36. The denominator becomes cube root of 6 times 36, which is 216, which is a perfect cube of 6 times 6 times 6. Right? That's like saying the cube root of 6 times 6 times 6. All right, and what is the cube root of 6 times 6 times 6 going to equal? 6. Oh, that was an ugly 6. I can do better than that. All right, not much better. Cube root 36. Now, I'll ask the same question that I just asked Quentin a moment ago. I'll ask it to Joe. Joe, I see a 6 on the bottom and a 36 on top. Can I simplify that fraction out? Correct. Why not? Yeah, and a root, as far as PEMDAS goes, a root is treated just like an exponent. Good. A root is treated just like a radical, right? Is treated just like an exponent as far as order of ops goes. That takes precedent over the divide by sign. So I can't cancel out anything in my answer. That answer right now is simplified. Okay, let's get down to the fun stuff before we run out of time. Any questions on example 5, by the way? Cube roots and whatnot. Again, a monomial over monomial. Boring. All right, Ben, go ahead. Correct. And then I'll see one better. What's 36? What is 36? 6 squared. So the cube root of 36 is the same thing as 6 to the 2/3. How now, brown cow? Look, right here. Man, what a great question, Ben. Okay, so like if you wanted to express this in, quote, exponential form, right? 36 is the same thing as 6 squared. And what's the phrase that pays, class? Oh, we had like 4 of y'all said that. What's the phrase that pays, class? Power over root. It's like this old show when I was a kid called He-Man, Masters of the Universe, right? Anybody remember Masters of the Universe and He-Man? Am I that old? Dude, He-Man was the bomb.com. He had a bad guy named Skeletor. Y'all ever heard of Skeletor? Everybody's daggum heard of Skeletor. Ain't nobody heard of He-Man. Anyway, He-Man would pull out this massive sword. You ever heard of He-Man?
Skeletor?
Yes.
Masters, yeah, absolutely. Guys, you don't know your He-Man? Well, listen up.
He would pull out this sword and he would say, by the power of Grayskull, I have the power. And then he would turn into like He-Man, this big jacked up guy. That's what I was going to ask. I can't remember the green tiger's name.
I'll be back.
Okay. Anyway, He-Man's a funny old show from the 80s that, power over root ought to be your call in these cases, okay? Because now we would say that's 6 to the 2/3 power. Now that's some algebra 2 coming down the line at you, okay? We don't deal with a lot of that in algebra 1, okay? But power over root is the phrase that pays, and it's how you're going to manipulate things back and forth between, the radical form, He-Man's normal. I think his name was Adam. Adam's normal form. But when he takes out the sword and becomes He-Man, he's this big old jacked up guy with a butt cut. All right. So we're done with monomial over monomial. Fabulous question, Ben. Okay. And now I want to get down to the fun stuff. Look at this. All right, now this is a good example. I tell students every year, and if you found that video on YouTube that I intended to show yesterday, I talk about it in that video. I cast down the gauntlet. The challenge is now issued, okay? What do you think would need to multiply by this fraction? What clever form of 1? Oh, James, you think you can answer the call? Be my guest. Square root of 3 over square root of 3. All right, fabulous. Let's write that down. Square root of 3 over square root of 3. Now, the numerator, right, it's 5 square root of 3. That's easy enough. The denominator being, the original denominator being a binomial. Alex, what property must I use to multiply by said binomial? The distributive property. So we're going to distribute this square root of 3 times both of these guys. And we're going to get 2 square root of 3 minus 9, square root of 9, which is 3, pardon me. Okay. Now, are we any better off than when we started? No. One might argue you're a little bit more complicated, Coach Morgan. And don't you dare, daggum, say, well, wait, Coach, look, square root of 3 on top, square root of 3 on bottom, cancel those out. As Quentin very astutely observed earlier, that minus sign would act as a block. So we're not even, I love you, James, but okay, so square root of 3 over square root of 3 did not work. We're going to have to get a little creative here, okay? We're going to have to get a little creative. I'll take one more guess, and then I'll let the cat out of the bag. Ben. Ooh, doggy. Now we're cooking, baby. All right, 2 minus square root of 3 over 2 minus square root of 3. All right, now the top is going to be cake. Just distribute, as we mentioned. So that's 10 minus 5 radical 3. Okay, Mossy, which process or which acronym do we use when we're multiplying a binomial times a binomial? We're going to FOIL it out. FOIL it out. Tiago, are you good at FOIL? FOIL this one for me. First times first. Outer. What kind of 2? Go ahead and do it. Go ahead and do it. Sorry, I cut you off. What kind of square root of 3? So the result would be -2 square root of 3. Okay, fabulous. Do the inner. Negative 2 square root of 3, and then do the last. This one's the hard one. You got to focus on this one. First of all, tell me the signage. It's a negative times a negative. So there you go. So it's going to be positive, and square root of 3 times square root of 3? 3. Good. All right. So we tally all that up. 4 and 3 make 7, and then who have I not talked to in a while? Reed, I don't know if I've talked to you at all. Reed, combine the two radical terms. What do you get? When we got the same root and the same radicand, right, we know all we have to do is just add or subtract their coefficients. And that root stays the same. So it's going to be square root of 3. How many square root of 3s? Good. Negative 4 square root of 3. Treat the radical just like a variable, right, guys? All right, now, is this any better? We got 7 minus 4 square root of 3. Is that any better? No, but why did I get so excited? Who was the one that gave me the answer? Ben? Why did I get so daggum excited about Ben's answer? We got to do a FOIL problem. Okay, okay. Jack? Similarly structured. Okay, that's true. That's not going to get the job done. Luke? All right. Oh, cancel out. No, roadblock. Let me ask you this. I've got it circled in orange. Reed and I were chatting about this, right? Adding like terms. Is there anything? Well, first of all, what part of my denominator is jacking my style up here? Is it the 7 or is it the 4 radical 3? Stay on 4 radical 3. Where did the 4 radical 3 come from? Where did Reed come up with that? From the FOIL problem. What part of the FOIL problem? F? The O and the I. That dratted O and I. If only, beard stroke, there was a way for me to have a FOIL problem where the outer and the inner canceled out. Quentin. Bum bum ba dun 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 bum bum ba dun 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 bum bum ba 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 bum bum ba dun. Y'all know that's the good Price is Right sound. Okay, so in other words, multiply by the C word, the conjugate of the denominator. And what happens now to my FOIL process? What happens to my FOIL process is that second 2 square root of 3 becomes a plus. Actually, it might be the first one that becomes a plus. Sorry, that first one becomes a plus, and the 3 becomes negative. Right? Tiago is doing the FOIL for us, and so now I've just shifted things a wee bit. And up at the top, this needs to be a plus, doesn't it? Right? All right. And then what happens to the O and the I now? They cancel out, and we're left with 4 minus 3, which is 1. So my denominator is just going to be 1, and then winner, chicken dinner. There's my answer. 10 plus 5 radical 3. Why is what? They're not opposites. They're conjugates. So like when we do, like, let me get this out of the way here. When we do the outer 2, we get a positive 2 square root of 3. And then when we do the inner 2, we get a negative 2 square root of 3. And the OI cancels out. That's by design. Okay, what Quentin remembered so well, and Quentin, I'm not surprised by that at all because I know you're a difference of 2 squares junkie just like myself. We love the difference of 2 squares. When we have the difference of 2 squares, factoring it out gives us a binomial times its conjugate. And then the reverse of that says when I multiply a binomial times its conjugate, the OI cancels out, and thus we are able to cancel out the binomial denominator. Now, real quick question. Go ahead. 10 plus 5 radical 3. Because it's over 1. Now, I'm going to give you something to chew on over the weekend. It's on this screen right here. Don't you dare look it up, okay? But every year, I challenge my 8th graders with this problem. I know we're running late, so I apologize. I know we're out of time. So as soon as you get this written down, skedaddle on out of here. But this is your challenge, okay? figure out how to simplify that fraction. Get the radicals out of the denominator. And I'll give you just a wee little hint. You can't do it just in one step. It's a multi-step problem. You won't get it done in just one try. All right? Live Jesus in our hearts. Thank you guys so much. Y'all have a wonderful day. Be safe out in the rain. By the time